Hello, everyone. In this section, we will move one step closer to controlling a drone with the LLM. Our main topic is Drone SDK Encapsulation. The goal is to wrap the original AirSim API inside a simpler and more semantic interface so that both human developers and LLM can operate the drone more easily. Let us first understand why this additional SDK layer is necessary. When a human pilot wants a drone to take off, the instruction is very simple, just take off. However, when we use original AirSync API, the process normally contains several technical steps. We need to create a client, establish a connection, enable API control, arm the motors, call a takeoff function, and then wait for the operations to finish. These low-level operations are useful for system control and safety, but they are unnecessarily complicated from the perspective of LLM. A language model should not need to remember every implementation detail of everything. Instead, it should be able to call a simple function such as takeoff, just as a human pilot would give a natural command. Therefore, we create a secondary SDK layer between the language model and AirSim. This layer hides low-level technical details and exposes a small set of manifold drone operations. The notebook introduces several important design principles for this wrapper. The first principle is semantic interface wrapping. An interface should describe an operation in a way that is easy for a human or a language model to understand. For example, AirSim uses the NED coordinate system, where a negative z value represents a positive altitude. This convention is technically correct, but it may be confusing for users. A semantic wrapper can allow the user to provide a positive altitude, such as 10 meters, and internally convert it into negative 10 for AirSim. The second principle is the atomic functionality. Each function should perform one clear and independent action. The third principle is standardized parameter. Inputs and output should use simple and consistent data structures. In this wrapper, positions can be represented as lists containing three values x, y, and z. And other principles are associated with operation of the drone, such as the silent error handling, unified physical units, context persistence, semantic alias mapping, async-to-sync conversion, sensor abstraction, and the safety boundary settings. We also recommend several additional improvements. Before executing an operation, the wrapper can check its preconditions. For example, it can verify that the drone is armed before takeoff. Different methods can also return a standardized structure containing information such as a success flag, a result value, and an error message. Now let us look at several typical encapsulation patterns. The takeoff method contains only one main airsim command, the takeoff async, and the land method follows the same pattern. And we could also use getUl method, which is slightly more complex. All these technical steps are hidden behind a simple function call. Now we could see the AirSim wrapper Python code. In there, we build a class named as AirSim wrapper. There, we could set up the function takeoff, the land, get drone position, flight to, flight path, set you, get to, and so on. Also, we could build the get distance function, and it will return the distance information. Also, when using dedicated frameworks later, there will be more specific requirements for function wrapping, such as the suggest menu, the get position. Now, we'll show you the SDK code test. How to launch the, firstly, we need to launch the AirSim simulator. And we need to run the code for launching the simulator. And in there, we could see the drone will fly. It will take off and fly to 20, 0, -10 position. And also we could run the land function. And we could see the drone is landing. It will cost some time. And that's all. Thank you.